The paper, CogniDual Framework, Self-Training Large Language Models Within a Dual System Theoretical Framework for Improving Cognitive Tasks, proposes a framework for self-training LLMs to improve your reasoning abilities. What's the core idea behind this CogniDual framework?
The CogniDual framework is based on the idea that LLMs can be trained to mimic the human cognitive system, which is often described by Kahneman's dual system theory. This theory posits that humans have two distinct cognitive systems. System 1, which is fast, intuitive, and operates on heuristics, and System 2, which is slower, more deliberate, and relies on logical reasoning. The framework aims to train LLMs to develop both System 1 and System 2 capabilities.
So how does the framework actually work? Can you walk us through the steps involved in training an LLM using this approach?
The framework involves a series of steps. First, the LLM is presented with reasoning questions without any explicit instructions on how to solve them. This is analogous to testing System 1's intuitive abilities. Next, the LLM is given the same questions, but this time with explicit instructions to use a chain of thought caught approach, which involves breaking down the problem into smaller steps and reasoning through them. This simulates System 2's deliberate reasoning process.
Interesting. So the LLM is essentially learning to reason both intuitively and logically. What happens after these initial steps?
The LLM then compares its responses generated with and without caught to the correct answers. The framework identifies instances where the LLM was able to provide a correct answer using caught, but failed to do so without it. These instances are then used to train the LLM further.
So the LLM is essentially learning from its own mistakes. How does the framework ensure that the LLM learns to provide concise answers without relying on caught?
The framework includes a step where the LLM is tasked with rewriting the detailed, reasoned answers generated using caught into concise answers. This helps the LLM internalize the reasoning process and learn to provide accurate answers without explicitly relying on caught.
That's a clever approach. What kind of results did the researchers find when they tested this framework?
The researchers found that LLMs trained using the CogniDual framework showed significant improvements in their ability to answer reasoning questions without caught. This suggests that the framework effectively helps LLMs develop System 1 like intuitive reasoning capabilities.
It's quite promising. Did the researchers test this framework on different types of LLMs and datasets?
Yes, they tested the framework on various LLMs, including Vicuna and Llama 2 models of different sizes, and on datasets like GSM-8K, Reclor, and LoGQA 2.0, which cover different types of reasoning tasks.
And what were the results across these different models and datasets?
The results showed that the framework was effective across different LLMs and datasets. Larger models generally required fewer training examples to achieve high performance without caught, indicating that they are more adept at learning from limited data.
So the framework seems to be a promising approach for improving the reasoning abilities of LLMs. What are the potential implications of this research?
This research has several potential implications. First, it suggests that LLMs can be trained to mimic the human cognitive system, which could lead to more human-like and intuitive AI systems. Second, the framework could help improve the efficiency of LLMs by reducing their reliance on caught, which can be computationally expensive.
That's interesting. Could this framework potentially lead to LLMs that can solve complex problems without requiring explicit instructions?
It's possible. The framework demonstrates that LLMs can learn to reason intuitively, which could enable them to solve problems that require creative thinking and problem-solving skills. However, it's important to note that this research is still in its early stages, and more research is needed to fully understand the potential of this framework.
That's a good point. What are some of the limitations of this research?
One limitation is that the framework was tested on a relatively small number of LLMs and datasets. Further research is needed to validate the framework on a wider range of models and tasks. Additionally, the framework relies on the LLM's ability to perform a self-evaluation, which is a challenging task for LLMs.
So there's still work to be done in terms of refining and validating this framework. What are some of the future directions for this research?
Future research could focus on exploring different methods for training LLMs to perform self-evaluation and on developing more sophisticated techniques for rewriting answers generated using caught. Additionally, researchers could investigate how to apply this framework to other types of cognitive tasks, such as decision-making and problem-solving.
This is a very interesting area of research. What are some of the potential ethical considerations related to this work?
As with any research involving AI, it's important to consider the ethical implications. For example, it's crucial to ensure that LLMs trained using this framework are not biased or discriminatory. Additionally, we need to be mindful of the potential for LLMs to be used for malicious purposes, such as generating fake news or manipulating people.
Thank you for this insightful discussion on the CogniDual framework. It's clear that this research has the potential to significantly advance our understanding of LLMs and their cognitive capabilities. It's exciting to see how this field continues to evolve.